We're going to walk through an application problem here of vector addition. So the problem says an airplane flies east 210 kilometers before turning 20 degrees east of south. So we'll have to figure out what that means. And flying 100 kilometers. And we're supposed to find the distance and direction from its starting point that the airplane is after traveling on these two paths. When you're done, sketch the vector addition triangle to show that the resultant vector makes sense geometrically. Label the vectors in the triangle. Actually, we're going to go ahead and make that vector triangle as we go. So the first thing I want to sketch is the airplane flies 200 kilometers east. So I put a coordinate grid, or just the north, south, east, west, up here on the top of our screen so we have that as a reference. So the plane flies 200 kilometers east. So I'm going to start at the origin, and I'm going to draw a vector that's 210 kilometers long. And I'm going to label this vector A. After that, the plane turns and starts traveling 20 degrees east of south. So 20 degrees east of south means we begin at going down at south, and then we come back 20 degrees. So in order to figure out where that is, I'm going to dash in. This would be south, and 20 degrees east of south means I would rotate 20 degrees towards the east. So that's up from the dash line that I just drew, 20 degrees. So this would be, we travel 100 kilometers in this direction, and this angle is 20 degrees east of south. And then our resultant vector, I'll draw that, let's say in green, is going to be from where we started to where we ended. And I'll label this vector R. The second vector I'm going to label as B. So what we're tasked with finding is, what is this resultant vector R? Okay, so R, the resultant, is going to be the vector A plus the vector B. And the issue is that we're given these vectors in polar form. We're given magnitude and direction. In order to add them, we're going to have to find their component forms. So let's begin with vector A. So vector A is pretty easy to put in component form because it's a horizontal vector and it's going just to the right. So vector A is 210, 0. Vector B, we're going to have to figure out what that component form is. So I'm going to draw vector B separately so that we can work with it. So vector B, remember, was 100 kilometers long, and its angle was 20 degrees east of south. But in terms of the angle that we're used to working with, is we always take it back to the horizontal, so be a reference angle. And that's going to be 70 degrees. And I'm going to move where I wrote 100. I'll put 100 on this side, 100 kilometers. And now we want to find the horizontal and vertical components of vector B. So I'm going to label the horizontal X and the vertical Y. I'm going to note right off the top that the Y component needs to be negative. So let's do some right triangle trig, so SOHCAHTOA. So I can say that, let's see, cosine of 70 degrees is going to be the X component over the magnitude of the vector, which is 100. So X is going to be 100 cosine 70 degrees. And if you enter that in your calculator in degree mode and round to one decimal place, you'll get 34.2. Likewise, we can say sine of 70 degrees is going to be the length of the opposite side. So I'll label these opposite adjacent, which is going to be y over the hypotenuse, which was 100. So y is going to be 100 sine 70 degrees. And if you enter that into your calculator, you get the y component of vector B turns out to be 94. But remember, we need to make that negative. So it's negative 94. So vector B is, in component form, is 34.2, negative 94.0. And now we are actually ready to find the resultant vector in component form. So r is going to be the a vector plus the b vector. The a vector was 210 comma 0 plus the b vector, which is 34.2 comma negative 94.0. If we add corresponding components, so we'll add the horizontal and vertical components, we'll get that r is equal to the sum of these two components is going to be 244.2 comma negative 94.0. So we've actually found our resultant vector in component form. But that's not what's requested for this problem. What's requested for this problem is that we need to find the distance and direction. So we need to find the distance and direction from the starting point. So the distance from the starting point is the magnitude of r. So let's find the magnitude of r. So I will go ahead and draw this just so that we have it. So our r vector, I'll redraw it, is negative, it's 244 to the right and negative 94 down. So something like this. So 244.2, negative 94.0. And we need to find this angle. I'll call it theta prime. And this is our vector r. So the magnitude of r, we're going to use Pythagorean theorem, is going to be the square root of 244.2 squared plus negative 94.0 squared. And if you put that in your calculator, it turns out to be 261.7 kilometers. And then we need the direction. So for the direction, we're going to use right triangle trig again. So we're going to say theta, or actually we're going to say tangent of theta is going to be the opposite over the adjacent length. So the opposite length is negative 94.0 over the length of the adjacent is 244.2. So theta is tangent inverse of negative 94.0 over 244.2. And if you enter that in your calculator, you get negative 21.0 degrees. We have to think, does that make sense in the fourth quadrant? And it does. A negative angle of negative 21 will put us in the fourth quadrant. So we have found what we needed to. So the resultant vector is 261.7 kilometers at negative 21.0 degrees. And if we wanted to, we could write that in terms of using terminology that they might use for a plane. So we could say 261.7 kilometers, and then our angle in terms of our direction. So if I want to think about our direction, we've got this was 21.0 degrees in the negative direction, and this would be east and this would be south. So we could say 261.7 kilometers, 21.0 degrees south of east. Either one of those descriptions is correct. They are equivalent.